So hey guys, I'm Jay Surya, and this video is all about the independent task for the GRIP, the Sparks Foundation internship. And to tell about my profile, I'm a data enthusiast. So these are the topics I deal with: Python, MySQL, machine learning, statistics, and Tableau. And to tell about my profile, I'm an experienced individual from a banking and logistics domains, descriptive analytics, and looking for jobs in data science field after pursuing a full-time PG program data science and engineering. So let's jump into the task. So this is the objective slide of the task. We're going to predict a supervised machine learning regression one, and the core objective of the task is going to be predict the percentage of a student based on the number of study hours. And it's going to be a simple linear regression task which have only two variables, one independent one and another dependent variable. And out of these tools, we're going to use Python in it. And so this is objective of the task. Let's get into the code file. So before getting into the task, so what is simple linear regression? Simple linear regression is about uh, independent column and a dependent column, and the relationship between both the columns. So whenever I speak about simple linear regression, it's only one independent column and another dependent column. And we got some linear regression assumptions. For example, the dependent column should be a continuous one or a discrete one. So those should be the some assumptions. But for a simple linear regressions, we don't want to get into assumptions part. So these are the libraries we're going to import: NumPy, Pandas, and Matplotlib and Seaborn for the visualization. And we're going to read the data set with the help of Pandas read CSV function. And this is how the data looks like. Two columns, one is R and another one is score. And yeah, understanding about the data, we got so before getting to into the machine learning algorithms, first we want to understand the data, what are the dynamics of the data. So we got two columns, and we don't have any null values here, and one comes with the float data type, another comes with the integer data type. So we want to understand, are there any outliers present in the column? Since both are the numerical ones, we are taking help from the box plot from the Seaborn, and we got to see that there are no any outliers present. Great. And to see about a distribution of the data, well, we cannot say that it's a normally distributed one, but we cannot expect normal distribution in real life data sets. So since it's only two variables, we're gonna go with the flow of what the data actually distributed. So we're gonna not we are not going to disturb anything in that. And to understand about the existing relationship between the independent variable and the dependent variable, we're going to make a regression plot with the help of Seaborn. And so we could see that that already slope present here. It's before predicting the algorithms. So we get into natural stuff, splitting the data as one. The reason why I have mentioned the double open bracket is so that we can have exactly like a data frame. If at all we take this double braces, it's going to be a series one. So if at all we have a data frame kind of thing, it's going to help us more to avoid errors or warnings. So that's the reason. And we can also go with this code, like just going with the values, that will also help us. And this is how the target column Y looks like. This is ours and this is scores. And we're going to split it with a simple train test split with a test size of 30%, a train test of 70%, with a random state of 100. So random state will help us when doesn't matter how many times we run the same cell, it's gonna give the particular value only. And these are the we could see that the split has been happened very perfectly. And first we want to try understanding the from the OLS, the ordinary least square method, so that first of all we could more than linear regression, before if at all we make into OLS method, we can clearly understand the relationship between the two between the independent variable and the dependent variable from the adjusted R square and from the intercept values, the coefficients values. So what we are trying to understand here is, first we're going to add the add constant and we're gonna make it to fit the model into OLS, and we're gonna print a summary. And from this, what we can understand is without any help of without there is no count of hours, a student can get about 1.5% over here without any hours. Even if a student will not study and go into the exams, he can score about 1.5%. And if the student studies for 1 hour, he can score about 9.9 or like 10%. So if a student studies for 1 hour, there's a chance of scoring more than 10%. So that's what this from the OLS we can derive, inference we can derive it. And so we getting the core of the tasks, we're going to go into linear regression from the scikit-learn package. First, we're going to train that model with extreme weighted. We're going to fit the algorithm with the extreme weighted, and we're going to train the model based on it. And first of all, before getting into the prediction part with the inbuilt function, we are trying to get the predicted ones with the manual formula. So the linear regression formula is all about y is equal to mx plus c, where we can also say that beta not plus beta 1 not x plus beta 1. So that's all we can also see. Yeah. So this is the manual package, but we're gonna see in detail in the inbuilt functions. So now we're gonna see about the actual versus unpredicted one relationship. The actual ones, this is the slope, the actual ones and the predicted ones. So the line going to be the slope, and the points are going to be the actual ones. So the distance between the is going to be the residual ones. Yeah. So now we are predicting the inbuilt function of the model, with the LM model that predict the X test. So with the help of the X test independent variable, we're gonna predict the target in one or the Y variables as this. This is going to be the predicted one. And these are actual y values, and these are the predicted y values. And the difference is we can see that in the data frame. The actual y values, the predicted one, and difference between the actual one are going to be errors or residual, something like that. And since we are done with the most of the thing, we're gonna evaluate the model performance, right? The R square value. Our R2 score is going to be a 93%. That's actually a good one. Because the model score is 93%. It's actually a good one. And now we are getting into the core objective of the task. If at all a student studies about 9.25 hours, how much the student can, how much the model can predict what the percentage of the students, or how much we can expect a student will be scoring out. So if at all a student studies about 9.25 hours, he can get about 92.8%, which is 93%. Yeah, so this is what we have predicted from our model, which was trained by the linear regression, which is trained by the X train, Y train. Yeah, and this is the business inference. From the prediction, we can say that if a student studies for 9.25 hours, the student can score up to 93%. It's not a mark; it should be percentage. Yeah, and the most important thing is not just about the R2 square. Sometimes R2 square can mislead us. Even in the OLS method, the R2 square can mislead. We should always check about the adjusted R square. And yeah, since adjusted R square is also good, but we're gonna see more about the residuals, errors. Less the error, good the model. That's what we can say. And we're gonna evaluate the model by the mean square error and the root mean square error. So RMSE is something very important thing for predicting, for evaluating the model, how good it was trained, how good it was fitted. So the RMSE is going to 5.0, which is according to the standards in industry, it is a very good RMSE. So yeah, that's the video, guys. This is the simple linear regression, and there's nothing complicated in it. And we'll see you guys in the next task. Thank you.